Hello! In the previous video, we talked about four basic components of power plants: the compressor, the expander, the boiler, and the condenser, and we showed a very simple cycle. A common question is, why do we need a condenser? After all, from 4 to 1, we reject heat to the environment, which we could have used elsewhere. A simple answer to this question is that our pump wants to operate with liquid fluids, so any vapor would destroy our pump, and our expander or turbine does not want any droplets, which again would destroy the blades of our turbine. So we need the condenser to take our saturated vapor and turn it to saturated liquid. But in the process, there's a lot of heat lost. Heat which we had to pay for in the combustion chamber. So what if we could use part of that heat? What if we could take some of the heat from here and use it to preheat our fluid here? So we need to use a heat exchanger. So take the fluid from 4, connect it to our heat exchanger, then pass the fluid in the condenser, and on the other side of the heat exchanger, preheat our incoming fluid from the exit of the pump. So this will act as a preheater before the boiler. Let's call this point X, and this point Y. So now the energy we need to offer on the combustion chamber is only H3 minus Hx. So right here, Q dot in equals over M dot equals H3 minus Hx. And the heat we reject on the condenser is less than before. It's only Q dot over M dot equals Hy minus H1. So now our thermal efficiency is not calculated as before, but the work of the turbine remains the same, the work of the pump remains the same, but the Q in we have to offer to the cycle is now H3 minus Hx. So the TS diagram remains pretty much as before, with the difference that the heat from 2 to 2x over here is offered from the preheater, and 4 to 4y goes to the preheater on the exit of the turbine. So for less fuel, we create the same generate the same energy as before. So we can define for the preheater the effectiveness. So let's call it N regeneration, for the regeneration. So the effectiveness shows how much of the theoretical heat we are actually taking. So it's defined as the ratio of the actual enthalpy increase in the regenerator, so Hx minus H2, okay, over the maximum theoretical enthalpy increase we could have, which that will be H4 minus H2. Another important parameter to define is the efficiency of the preheater. So let's assume that the efficiency is 1. In this case, all the heat that this stream from the turbine to the condenser lost went to the stream from the pump to the boiler. In other words, Hx minus H2 times the mass flow rate will equal the mass flow rate times H4 minus Hy. Obviously, in this application, the mass flow rate is the same, so we can ignore it.